Hello everyone. In this tutorial video, I'd like to give you a basic introduction to how exponential functions work. So that way, we can use these basic definitions as proofs of more complicated operations involving exponential functions. An exponential function of the form a to the power of n is exactly equal to a times a times a times a, etc. n times. This is similar to how multiplication works when you first learn its basic definition of a times n equals a plus itself n times. One caveat with exponential functions, however, is that with a negative number raised to a power, you have to pay attention to if the negative number is in parentheses or not. If it is in parentheses, it is raising the negative number directly to the exponent, and if it is not in parentheses, it is doing the exponent on the positive integer and tacking the negative sign only and only after you have computed your result. So they will give you two distinct answers. It should follow by the basic definition of what an exponential function is, where the base is a variable and the exponent is a constant. That if we do something like a squared multiplied by a cubed, it means a times a times a times a times a. So we conclude that a to the power of n plus m is exactly equal to a to the power of n times a to the power of m. Likewise, if we have a to the power of m divided by a to the power of n, and we have specific values of 4 for m and 2 for n, this means we have a multiplied by itself 4 times over a multiplied by itself 2 times. And two of the factors in the numerator cancel out because we have exactly two factors in the denominator. And we conclude that a to the power of m divided by a to the power of n is exactly equal to a to the power of m minus n. If we have a to the power of n raised to the power of m, i.e. a composite exponential function, we will use 2 as the inner exponent and 3 as the outer exponent as a specific case. We see that a raised to the power of 2, or a squared, is a times a in the parentheses, and then that result is cubed. So this means we have a times a one time, times a times a, times a times a. This means we have a multiplied by itself 6 times, so we conclude that if we raise an exponent to another exponent, we simply multiply the exponents, provided that they have the same base. Using what we derived as one of our rules, i.e. that a division of exponents causes one base raised to the power of the subtraction, we can prove exactly what a raised to the power of 0 and a to the power of negative 1 must be. We remember from arithmetic patterns that 0 can be derived as a number minus itself, so it should follow that a raised to the power of 0 can be rewritten as a to the power of n minus n, which by properties of exponents is a to the power of n over a to the power of n. We see, since the numerator and denominator are exactly equal to each other, the result must be 1 by properties of division, so we conclude in short a to the power of 0 equals 1. By similar reasoning, if we subtract the exponent one more time to get negative 1, we see the denominator has one extra factor and only one that the numerator does not. We should conclude that a raised to the power of negative 1 equals 1 over a. These numbers may seem very arbitrary or bizarre when you first look at them, but using what we know from properties of exponents, it becomes clear that they have a logical reason why they have their values. Since we remember raising an exponent to another exponent simply causes the exponents to multiply, it should follow that we can rewrite a negative exponent besides negative 1 as negative 1 times the positive counterpart to the number by rules of arithmetic. So this means a raised to the power of negative 2 is 1 over a squared. And you can also see this is true by using the exponent subtraction rule as well, i.e. by subtracting one more time So this means the denominator has one extra factor that the numerator does not. And either proof works, and you get the same result. Now that we have figured out the basic properties of exponents with integer numbers, we can figure out rational exponents, or exponents who are ratios. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.